So looking at exponent rules, we must be really careful to not make mistakes with the rules. We need to make sure we know our rules. Again, the rules were when we multiply exponents of the same base, so we have x to the power a times x to the power b, we can count the number of times we multiply together by adding the exponent. If we divide exponents of the same base, and again the bases have to match, we can take away the division from the multiplication and subtract exponents. And the other rule is that if we have power to power, we are able to count in groups, so we multiply those exponents. And I mentioned before that exponents and add and subtract do not mix. Okay, so if I have x plus y squared, for example, we cannot square when there's pluses and minuses. So this is never equal to, we can never square when there's pluses and minuses. Okay, if you want to do this, and we can deal with this by converting it to multiplication, because multiplication and addition subtraction we can deal with. So we can convert this to multiplication instead of squaring, and again remember powers and multiplication are different. Okay, and this can be done. Okay, and we end up with distributing it out, we end up with x squared. We have to distribute x times x, x times y, y times x. But this is really just multiplication and addition, which involves distribution. Okay, and notice that these are not equivalent. X plus y times x plus y is equal to this. X plus y, if we square it individually, we do not get that, so they cannot be done. So the big idea though is that addition and subtraction cannot mix with powers and roots. So here are some other mistakes that we sometimes do. So the mistake here is a mistake in the exponent, or is it in the base? Well, in this case it's a base, because we never divide or multiply bases. Okay, the base tells us what we're counting, so we have to keep the same base. So the correct answer would be, we'd have to, so this is wrong, this would have to stay the same base, and then we can subtract the exponents. So we never divide bases. Okay, so here really is the same problem. The exponents are actually counting the same, but we have different bases, so we cannot apply exponent rules and we cannot add those exponents. Okay, here we've multiplied the bases as well. You can never multiply the bases. Okay, so if we can't divide the base, we can't multiply the base either. So whenever there's a rule for multiplication, the same rule applies for division because it's the same property. Here we have the negative number and negative power. Well, these two negatives actually mean totally different things. Okay, so the negative power is definitely to divide, okay, but this negative base does not have anything to do with division. So we have to make sure that the negative power has nothing to do with the negative number. Okay, so the negative power and the negative number do not mix. Okay, this is divide. That really means divide. Okay, so this is not true. What does work is, so this is equal to 1 over negative a, all in brackets, cubed. That's correct.